for each and everything you've done in our lives. Father, as we're going to start our lesson, come and be in the midst of us. Come, in Jesus' name I've prayed. Amen.
Amen. So thank you so much, Daphne,
You're
for
welcome,
giving
sir.
us that opening prayer. I hope all of us now are filled with the Holy Spirit and in the mood of attending to our lesson. So I welcome you all to this afternoon lesson of chemistry. Welcome, and I thank you so much for your commitment to our main cause. All of us here want to take this opportunity so that we can get something out of it, not giving excuses at the end of the day. You know, one man said that excuses are the nails used to build the house of failure. So every time you have an excuse towards your success, just know you are building a big house. You are building a mansion for failure. So we shouldn't give any excuse towards our success in life. So I thank you so much for that. Then before we start, also I want to talk about the assignment. Normally we send in assignments in your classroom for you to attempt to try out to see how far you have understood, so that if in case something is lacking, we can go back and correct it. But the moment you don't attempt that work or that assignment, it really looks bad, because there is no how we can tell that you understood or you didn't without getting any feedback from you. And how do we get the feedback? It is by giving you a simple assignment for you to try out on your own. So whenever we give out assignments, please let's try our best to do the assignment, just like how the teachers try their best to make sure that that assignment is posted in your Google Classroom and in time. We will really try our best to make sure that that work comes early enough for you to attempt. Some of you might be having those excuses, teacher, we are at home, we do the chores, we do what, some graze animals, but that's not the case. Those excuses are lame, they won't work. Try and get time. We have 24 hours in a day, so you can't say that you attend to your animals, to your siblings, or doing the chores the whole day. Alright, so let's first have a recap of our lesson. That is the lesson we had. And please, in case you're not around in the other lesson, I hope you come to my inbox or in the chat here. You let me know. And this is senior 3 chemistry. So if you are here, you are in senior 1, you are in senior 2, senior 5, you are in the wrong class. And the subject is chemistry. By saying this, I'm trying to avoid questions like, teacher, which class is this one? Is this senior 2? Is this English? Is this S.3? You can imagine. And normally you come at the end of the lesson asking that. Let's avoid that. Let's always read the timetable clearly and we understand where to go. So the other time there is something that we didn't look at. We had looked at these metals, occurrency, then extraction of metals. We gave reasons. We also gave the reactivity series, which helped us to find the good methods for extracting these metals, just like here how we are saying. Remember, this is what we covered last time, how we are saying that if you have potassium aluminium, then you would use electrolysis. Reason, these ones are very reactive metals and also very stable. They form very stable compounds, so we use electrolysis to extract such metals. And if you have, let's say, zinc, iron, lead, or copper, then these are moderately reactive. Then you would use methods like reduction of the ores using either carbon or carbon monoxide as reducing agent. So there I would choose one of them. But normally we use carbon monoxide, and the ores are oxides, as we shall see. Oxides can be sulfides or carbonates. So these are the ones which are common. These are the ones which are common. Then lastly, we say that if it is mercury, silver, and gold, we are saying that these are not very reactive. These are not very reactive, and therefore they can also be found as free elements. This is very important. In other words, they are the easiest to extract. They are the easiest to extract since they form unstable compounds. So these ones are easier to get, and they can also be extracted by mere heating the ore. When we talk of mere heating the ore, that is simple heating. That is simple heating. Yes, Grace. Grace? Nachitenda? Grace, I'm unable to hear you. I don't know why. Can you use the chat? I request that you use the chat so that I can read. Right now I'm not hearing, but I'm sure I can read. So let's use the chat. Thank you. Alvin, those are things I was talking about. You didn't attend the first lesson, and we shall need to have maybe a separate session so that I can take you through that. You can reach my inbox, then we arrange for a separate session or lesson. Because if you are to go back through all this work, then we shall spend too much time and we shall not have any progress. But I pledge my time that if you approach me, then we can have the lesson. Benjamin, you're saying that you don't have the notes. I think that one is not my problem right now, because I did my part. I posted the notes in our Google Classroom, so you check there. You check there for them. Thank you. Then from here we went on and said we looked at sodium. We looked at the principal ores, or the ores that we use to extract sodium. We said rock salt. If you have to remember when I said that this is the name. This is the name of the ore, rock salt. Then the chemical name, now we are adding there the chemical name. The chemical name, it is sodium chloride. The chemical name of the ore is sodium chloride. Then the chemical formula. The chemical formula is like that. In other words, what I mean is like this. The question might come asking you the name of the ore. So the name of the ore is rock salt. Let's get that, rock salt. Then the chemical name, now we add the word chemical. Chemical name, the chemical name, it is sodium chloride. Sodium chloride. Then chemical formula. Chemical formula of the ore. That is, let me expand this. That is that. Clear? So that is how the questions will be set. Name the ore, rock salt. Chemical name, sodium chloride. Chemical formula, NaCl. And that it works for all the ores, not only sodium chloride. We are just speaking out that. Okay, I hope it is clear. Okay, you can check your chat. Mr. Dumba has put there something which is important. You can check it out. Especially Benjamin. Benjamin, check in the chat and see what the chat has posted there. Then we continued. We continued and looked at the. We looked at soda ash, also another ore, sodium nitrate, like that. So these are different ores for sodium, on how we can extract sodium. Then extraction of sodium. So here we want to look at exact extraction of sodium. How do we extract sodium? So we had the method. We said since it's a very reactive metal, we use electrolysis, and we said that we add there also sodium, we add there calcium chloride. So this is something that we looked at. So now my concern now, what we should look at, what we didn't look at. I want us first watch this video. Let me share it again. I've not shared the sound, and I know some of you might not hear. Okay, this is the diagram or the video that we watched. So I want us to watch it again, then I go on and explain what comes next. So open your ears as well as your eyes, and you see what is happening in the video. In case you have any issues with my network or my voice, come to my inbox and I see how to add a third microphone so that everyone can hear me clearly.
Sodium metal is commercially prepared by Downs process. The cell is made up of iron box, lined with fire bricks. Graphite anode is placed at the center of the tank, and ring-shaped iron cathode is placed outside the anode. The cathode and
the video is playing very slowly. Let me get you. Meanwhile, let me get you the one which is a bit faster. Sorry about that. So now if you have any questions, you can be asking as I get the video. If you have any questions, you can ask.
sodium metal is commercial.
Okay, so I've already got it. So that is our video. I think we watched it, but I want us to watch it again so that we simplify what is coming next. Make sure you take notes, because what is coming next, I will just be rushing. Make sure you take notes if you didn't take notes the other time.
Sodium metal is commercially prepared by Downs process. The cell is made up of iron box, lined with fire bricks. Graphite anode is placed at the center of the tank, and ring-shaped iron cathode is placed outside the anode. The cathode and anode is separated by iron screen. This screen separates sodium and chlorine ions. A mixture of sodium chloride and calcium chloride is poured in the cylinder. Calcium chloride is added to decrease the temperature of NaCl. When electricity is passed through the cell, NaCl breaks down into its components. Sodium ions are collected at cathode, and chlorine ions moves towards the anode. The reaction at cathode is sodium ions reduce at cathode and forms sodium metal. The reaction at anode is chlorine ions are oxidized to give chlorine gas. Liquid sodium rises up and is stored in a container. 99.9% pure sodium metal is collected in the container. The chlorine gas is collected from the top of the cell.
Okay, so that is our video that we watched last time. So this one is going to help us explain our process very well. So here I was supposed to be having the video, but it was a bit slower, so that's why I moved it. So this is the whole thing. This is what we've just watched. The down cell has an outer iron shell, an outer iron shell lined with a fire brick. We looked at that. Then iron goo cylinders separated by the graphite anode from the ring, iron cathode, and we said this prevents the mixing of the products at the different electrodes. So we are having iron goos that separates the mixing of the two products. So if you are to go back, this is what we mean. This is our diagram. It's just a cross section of what we've just looked at. So we are having here, this is what we call, this is our anode, and this is our cathode, which is made of iron. Remember, the reason as why we are using carbon as the anode or graphite, because if you remember well, graphite is the same as carbon, because graphite is made of carbon. So when we say graphite or we say carbon, it's the same thing. So the reason as why we use carbon is because we are producing chlorine at the anode, and chlorine does not easily attack anode. Or we normally say that carbon is not easily attacked by chlorine. Chlorine is a very reactive gas, so it attacks many nanometals. But for the case of carbon, the reaction is there, but very slow. So we are saying it is because if they ask you why do we use anodes made of carbon, it is because anodes chlorine anodes carbon is not easily attacked by chlorine. So that's the reason. Yes, Ivy, you are saying that I'm breaking. It could be my network. I'm sorry about that. Then secondly, we are having our cathode. Remember, we are having the electrolytes. I don't know whether you've done electrolysis, but in electrolysis we have what we call let me write here. We have what we call an electrolyte. Which breaks down or which decomposes when electric current is passed through it. So in this case, our electrolyte is sodium chloride. Our electrolyte is sodium. It is sodium chloride. I will write the formula to save time. Sodium chloride. Then we have the anode, the positively charged electrode. So this is the positive charged electrode, just like how we look at car batteries or solar batteries, how they have the positive terminal and the negative terminal, and we call them electrodes. So our anode, that is the positive charged terminal, and that one is made of carbon, or at times we can say graphite. You'll find that some books say graphite. Then we also have the cathode, that is the negatively charged electrode or terminal, and that is iron. It is made of iron. So what happens is that the positive charge or the positive terminal, which is anode, it attracts, so the positive ions, they are attracted to the cathode, then the negative ions are attracted to the anode. So if you haven't covered electrolysis, it would be maybe a bit complicated, but when we cover electrolysis, I'm sure that we shall come to understand. So I don't want to go into the details of electrolysis. It is a full topic, but basically these are what we can take as per now. Electrolyte, that substance that decomposes when electric current is passed through it. Then we have the anode, which is a positively charged terminal. Then the cathode, which is the negatively charged terminal. Yes, Nation, you're saying that you're not hearing me clearly. It could be my network or it could be yours. So we need all to check our network. Okay. So members, as I said, this is our diagram. And we continue. So we are saying that at high current, that is when we pass through the system, the current. Remember I said that electrolyte we're having can decompose when electric current is passed through it. So high current is used to keep the electrolyte in a molten state. What do we mean by molten state? To make sure that it keeps in that liquid state. If you ever seen where they heat saucepan, rather metals, to make saucepans, normally they heat the metal and it melts. It gets into a liquid form, just like how we see like cooking oil. It is always as thick as that. Then chlorine escapes through the wood or via the wood, and I'd shown you the wood. If we go back, the wood is this one. The wood is this one on top. The wood. So this is the wood, the one on top. Then again, so this is the brick wall we're talking about. This is the brick wall. Maybe let me use the video. I think it looks better. Let me use the video.
Sodium metal is commercially prepared by Downs process. The iron cathode is plate-shaped iron.
The video. This is our graphite, which I said is the same as carbon. So this is the anodes. Then here we are having this thing here that we are saying. This one is the cathode, which is connected here. Then the wood. Now the wood would be this one. So our chlorine will escape through here. Then our sodium will collect in this cylinder. So this is a better thing. This is a better view. So like that. So this is the brick wall we're talking about. You can see these ones look like bricks when you cut through a wall. So this is what we mean by a brick wall. Okay. Then so the sodium collects in the inverted trough, like I showed you. Then sodium metal is collected upwardly in a down state because of its low density. It makes it to float over the reacting mixture. So for more information about this Downs process, we shall keep on watching the video. I think it is more clear. So reaction at the cathode, we are just repeating what is already in the video. Reaction at the cathode, we say this is negatively charged electrode. So we shall have sodium ions to be attracted there, because for them they are positively are charged. They are positively charged. How do we get them? When the other high current of 30,000 amps passes through the electrolyte or the sodium chloride, it will decompose to give us two ions or two types of ions: sodium ions, which are positively charged, and also the chloride ions, which are negatively charged. So in electrolysis, it is always that the anode or the positively charged anode, rather positively charged electrode, attracts the chloride ions or the negatively charged ions. They could be chloride, they could be sulfate, they could be nitrate, as long as they have a minus charge. Then the cathode, which is negatively charged terminal, will attract the positively charged ions. In this case, they are sodium ions. You can have potassium ions, you can have copper ions, so depending on which metal you are having. So sodium ions gain electrons and therefore are discharged to form sodium metal, which is deposited in a molten state and collected over dry nitrogen. Why do we use the nitrogen to collect sodium? It is because nitrogen is inert and it won't react with sodium. Like we said at the beginning, that sodium is a very reactive element, so it reacts with most of the other elements. So we need that element that will not allow the reaction to take place. So that's why we are using nitrogen. Nitrogen is not reactive because of its triple bonds. Because of its triple bonds, which are hard to break during the reaction. So that is the equation which we already have. Let's look at what happens at the cathode, at the anode. At the anode, remember I said this is the positively charged electrode or terminal. It is going to attract the negatively charged ions, and in this case we have chloride ions. In this case we have chloride ions. This is supposed to be D. It is supposed to be chloride ions, not chlorine ions. So at the anode, chloride ions are discharged as they lose electrons to form chlorine atoms, and the chlorine atoms pair up, forming chlorine molecules or gas. What do we mean by pairing up? It is that when we are forming these chlorine atoms, we form the first one, we form the second one, so they will pair up. They'll just form one pair, and we get the molecule, which is a chlorine gas, which is collected as a valuable product. But since we are looking at extraction of sodium, chlorine is just a byproduct. It is the minor product. The major product or the main product is sodium. So if they ask you the extraction of sodium, make sure you have that equation for the formation of sodium. Then that one of chlorine comes later, given that it is a byproduct. So can I have like 2 questions and we proceed? 2 questions. Anybody with 2 questions? 2 questions?
Teacher Oswald.
Yes, please.
Will you, in the chat, Maria Tracy wasn't even sure what we were doing. So maybe you can just have a recap for them what the topic is about, and then they can follow the rest from the YouTube videos.
Okay. So let me also get the question so that I can repeat at once. Only 2 questions, Maria. Maria, we have many hands up.
Master, when you're talking about the reactions, is it okay when you talk about the color changes, like you speak the color for sodium, the color for chlorine?
Yeah, it is okay. It is okay. Sodium, it is a gray metal. It is gray metal. Then chlorine gas, which is formed at the anode, it is a yellowish green gas. A yellowish green gas. So those are two colors that we
Okay.
have. Then Veronica, or I think you call yourself Vero. Virunji. Unmute and ask. Okay, the chance. Then from Melissa. Melissa,
Sir,
unmute.
Just also.
Excuse
The
me, Chair,
thing
my
is,
question clarified
Yes, please.
on why the cathode of iron.
Is iron or is carbon?
teacher,
Okay,
also,
Melissa.
teacher Oswald, I was asking,
Yes, please.
I don't get this part of the reaction at the anode. I didn't get that part properly.
Okay, fine. Let me see how I can repeat it, and I simplify the language. You can lower your hand so that we don't confuse each other. Okay, thank you. Liam, you are saying that I should share the equation. No, there is no need of sharing. Already I was sending these notes to your classroom, so you have your time to copy everything. Only that there are some things that I talk about that are not involved in our notes. Since we are having a presentation, we don't put everything, but some we talk about them. Linda is asking, do we need to include the experiment? No, there is no need, unless if the question is asking for it. If the question is saying that describe the Downs process, then you have to explain that is the experiment you need to explain. But if it is not about that, then you don't need to. At times, this whole process can be broken down. It can be broken down, and they ask you different parts. For example, here they can ask you to write the equation at the anode. Equation at the anode. Then they can ask you, why do we use carbon as the anode? Or they can ask you, what is the color of the product formed at the anode, or what is the nature? Is it a solid or it is a gas? That is how the questions can come. That is if they don't ask you to explain the whole process. So it depends on how the question is set. So for those people who just came in and they don't know where we are looking at that part of chemistry that we call applied chemistry, and basically we are looking at metals and how they can be extracted. So we have different metals and we have different methods that we use to extract them. So we said that if it is if the metal is in the league of potassium, sodium, magnesium, calcium, and aluminium, we use electrolysis because metals are very reactive and they form stable compounds. Then we also had a moderately reactive metals, and we had there copper, we have lead, we have zinc. Those ones we use reduction, or we use their oxides, and then we reduce the oxides using either carbon monoxide or carbon, like that. Then we looked at sodium as a metal, its extraction. So you found us on the extraction of sodium. So, but for more information, you will have a link to our YouTube. That is where we posted the lesson from the first minute to the last minute. So you need to check there. Someone is asking, why is chlorine discharged? Why is the chlorine ion discharged? It is because it requires less energy to be discharged. Discharge is like converting it from an ion form to a molecular form. And it is under electrolysis, and I say that if you haven't covered electrolysis, then we shall see how to do that so that we can all be at the same page. Yeah, I'm being too fast because I'm repeating what I've already talked about. This lesson is being recorded, so there is no need of going back each and every time. You check, you go on the YouTube and it will be there. It's just a matter of going there, you get the link, and then you have whatever I said before when I was a bit slower. Okay, I hope it is clear to you. So this is the equation of what happens at the anode. We have the chloride ions, which are discharged in the form of the chlorine gas. Then you say we're having 2e. Here we mean 2 electrons. This here we mean 2 electrons, and we are trying to balance the charges. So we have a minus, also a minus here, and here we don't have a charge, and all of them are supposed to be balanced. So this is the same as having 2 times minus 1. 2 times minus 1. I'm just getting this 2 then times this minus here. Then minus an electron is negatively charged. If you still remember, an electron is negatively charged. I request K, you can switch off your video. So minus, this is 2 times this minus, which is on the electron. An electron is negatively charged, so we put a minus again here. Yeah, this one is longer, but we can go with it. So it's the same as having minus 2, then minus 2. Mathematically, a minus times a minus, we get a positive. So it becomes minus 2, then plus 2, which gives us 0. So on the left we have 0 charge, and also on the right we have 0 charge. Someone is asking, why do we use Downsen to extract sodium? It is because it has all the qualities. It has all the conditions that are required for sodium to be extracted. Then from there, let's look at the uses of sodium. Okay, thank you, Mr. Dumba. So we'll look at the uses of sodium. It is used in the manufacture of sodium cyanide, which is used in the extraction of gold. Some members here, we are not saying that sodium is used in the extraction of gold. It is only used to manufacture sodium cyanide that is later used in the extraction of gold. So we shouldn't make that mistake of saying that sodium is used in the extraction of gold. No, that is wrong. Then secondly, it is used in the manufacture of sodium amide. It is also used in the manufacture of sodium peroxide. Remember we looked at sodium peroxide during the preparation of oxygen in the lab. Then it is also, it's an alloy. If it is used in the manufacture of anti-knock additives for petrol, e.g. tetraethylene lead. So those are just additives that are added to petrol. Then it is also used for the withdrawal of heat from some nuclear reactors. Therefore, it can be used as a coolant. So this one, we have the details in physics. That's why we have a full detail of this. So you can also consult physics teacher. Then We also use sodium vapor lamps. Sodium vapor lamps are used for street lighting. So that's what we can do, or what we can say about sodium. So before we cross to another metal, can we have questions? Only 4 questions. If your network is not stable, or if you are not hearing me clearly, you can use the chat. It would be the best option. So 4 questions, and if there is none, then we shall continue. It seems everyone is understanding the way I want it. Any questions? Okay. So someone is asking, why is sodium collected not released like chlorine? Sodium is collected because it's what we are extracting, it's what we are looking for. Like I said, that it is the major product, it is what we want in this process. So we need to collect it so that it can be used for other things, like we look at the uses. Then I said the chlorine, it is a byproduct. It is just a minor product. It is just a minor product. It's just like when you go for a party and you are the best man. So the best man is also part of the party, but is not the main person there. It is the groom. So that is our chlorine. So the party can be there without the best man, but it might stop when there is no groom. So you can compare the two in that sense. I'm not saying that you shouldn't become best man for your friends, please. Ben? Ben, unmute. It seems Ben was testing his hand to see where it can be raised. Okay. Arlene, your question is not clear. So let's now look at the extraction of intermediate metals. Extraction of intermediate metals. So what do we mean? The ones we say that they are moderately reactive. The likes of zinc. The likes of zinc, we had copper. Which other element do we have? So the intermediate, those are the ones which are moderately reactive. Yes, Brenda?
So why of sodium peroxide solution?
I beg your pardon? Can you again hear your question? So I think Brenda, we shall come back for. I didn't hear the question. Use the chat. So let's look at the intermediate metals, or the moderately reactive metals. How can they be extracted? So we are just picking one metal from the groups we have. For the ones which are very reactive, we picked sodium, and for these ones which are moderately reactive, we shall pick also one. So metals are extracted by reduction, like we talked about it. Metals are extracted by reduction, and they have 4 basic stages. So we have some stages we go through to reach that stage of reduction. So let's look at those stages. 1, we have concentration of the ore. We talked about concentration of the ore in our very first lesson. Can someone remind us what we meant by concentration of the ore? You can raise up your hand so that we can also add you to our records that you gave an answer during a Zoom lesson in the year 2021 in the month of September. So can someone remind us what we meant by concentration of the ore? Can someone, please raise up your hand so that you can be able to give us the answer, or you can use the chat. I will read out your answer loud and clear. Yes, a blessing.
By removing the ore from other impurities.
Blessing is saying that it is removing the ore from other impurities.
No, like removing the wanted element from other impurities in the ore.
Okay, what if you said removing the ore from other unwanted impurities? How do you see that?
Okay.
Okay, thank you. So blessing has said that removing the ore from other impurities. Remember we said that concentration of the ore is the same as purifying the ore. Purifying the ore, that is removing other impurities. These ores come with other impurities which are minor. And remember we say that an ore, it must be in high concentration or in high percentage. So the impurities must be in smaller percentages. Okay, so that's what we do first. We have also other answers in the chat. Mark says that the process of removing unwanted material from the ore. Thank you. Maria says the reaction of the ore. Okay. Then someone has a name here you can't pronounce. Okay, Francis. Francis says thank you, sir. You are welcome. So here, during the concentration, we shall purify our ore. We shall purify our ore, just like how modern has said it. Then secondly, we have that stage of roasting the ore. Why do we roast the ore? Why do we roast the ore? It is because we want to convert the carbonates and sulfides to oxides. We want to convert the carbonates, the sulfides to oxides. Remember, these carbonates are also the ores. Carbonates are the ores of these elements, so we need to convert them to oxides and also remove water vapor, because the oxides are easier to reduce. The oxides are easier to reduce than reducing the carbonates. So if they ask you the use of roasting the ore, that is after being concentrated or purified, the reason is to convert the carbonates and sulfides to oxides and also remove the water vapor. Reason, the oxides are easier to reduce than the carbonate. Take an example. Take an example of the ore of iron, the one we saw at the beginning, the one we called iron, which we said it is iron 2 carbonate. So what we need to do here is to roast this ore after being purified, meaning that we shall be having our ore to, we need to heat it or roast. When we say roasting, we mean heating it in oxygen, or what we call combustion. So here we shall get the oxide. We shall get the oxide, which is iron 3 oxide. This is supposed to be a 2. That is supposed to be a 2. So here we're supposed to be this, like this. Iron 3 oxide and also carbon dioxide. Remember, whenever you heat a carbonate, it must produce carbon dioxide. If it is a sulfate or a sulfide, it will produce a sulfur dioxide gas. So our main aim of roasting it is make sure that we have this, which is easier to reduce. So having formed iron 2 oxide, iron 3 oxide, so we can easily reduce it. We can easily reduce it. I don't know why I'm writing the 3 again. We can easily reduce it. Find that here a 2 again, a 3. This is iron 3 oxide. I'm just giving an we can add or carbon. If I carbon, then subtracting and carbon dioxide but which the details, don't worry. Go to the third ore. So and anox, then is saying that can we, or it must be roasting. Let's say heating. You can say heating, but you have to involve say heating in oxygen. And then lastly, we look at purification or refining of the metal extracted. So here we are purifying. In this last stage, we are purifying the metal which is already extracted. We shouldn't confuse it with purification of the ore. Here we are purifying the metal that is already extracted, or what we can call refining of the metal. So those are the basic 4 stages that we go through during the extraction of the intermediate metals. So if they ask for them in, for example, in paper 2, then you should be able to write them down and explain them as well. So let's see what really happens during the concentration of the ore. We're just repeating what we looked at or what I've been talking about. So this involves a removing of the impurities. So we are to remove all the impurities associated with ore. Impurities can be separated by physical means. I mean here we don't need the chemicals. We can use physical means without applying any chemical. Picking the by hand, just like how rice. So rice you remain with that you want to, or you them in it. You can use a during some for it to
Afternoon, class. Good afternoon, class. Okay, teacher Oswald is back. We had lost him. Welcome back, teacher Oswald. Hello, Oswald. Hello. Afternoon.
When you get that list of participants appearing at your name, actually your name will be at the top of the list.
Hello.
Your name. They are supposed to greet you.
Teacher Oswald, are you back? Hello.
Yes, please, I'm back.
Yeah, sorry, we had lost you. You can continue.
Someone had scared my network and it went off. So let's have our screen back so that I'll share the wrong document. So we are looking at this first stage of concentration of the ore, and we say this we can use these different methods or means. Then after that, during this stage, in case we have a metal like copper, if we have a copper ore, what we do, we first crush it. So if it is in big particles, we just crush it into small particles. Normally we say into fine powder. So we first crush it, or we grind it. We can also use the word grinding. Then we mix it with water, and air is then blown through the mixture, and the clean ore separates and collects at the surface as froth, and this is referred to as froth flotation. So when they ask you to define the term froth flotation, that is the concentration of copper ore. What do I mean when I say froth? It's like when you have soup, let's say meat, and you have the soup, and at times the cream, those parts collect on the surface. So you find that on the surface you have the good soup, then inside there you have the water. So that is our froth. Our froth is that cream that it is always on top of your soup. I'm just giving that example. I'm not saying that froth is the cream. And again, we shall have the taste of this of extraction of copper later. Then roasting, we say during roasting we just heat the concentrated ore. So here we say that the concentrated ore or the pure ore is roasted or heated in air at high temperatures. So here we use high temperatures to produce oxides, which are easier to reduce than carbonates or sulfides. Remember we say that these ores for the intermediate metals, some of them are carbonates and some are sulfides. So what we do, we heat them in air. What do we mean by air? When we say air, in air there is oxygen, and it is that oxygen that supports burning. So in this case we can say that oxygen supports the roasting of the ore. In other words, heating these carbonates or the sulfides with that oxygen in air to give us the oxides, which we said are easier to reduce using our commonest reducing agents. Then sulfur. Sulfur is contained in sulfides. Sulfur is removed as sulfur dioxide. Then carbon dioxide driven off from the carbonates. So if you have the sulfide, if the ore is a sulfide, after heating, we shall remove the sulfide or the sulfur in the sulfide as sulfur dioxide, which escapes as a gas. Then the carbonates, we shall have carbon dioxide. Yes, Angel, you have a question?
Lost my network was disturbing. Which topic is this?
Angel, this time you're asking for the topic. The
Teacher, my
topic is
network was disturbing.
yeah, you will check. I request that you check in the our chat, and also you'll be given a link to the YouTube. Our lesson is live on YouTube, so you go there and check. I'm sorry that I can't repeat as per now. So let's continue. Let's continue. We got the reduction of the ore. Remember, now we already have the oxide, which we said that they are easier to be reduced. So that is where we are now. So what happens there is that the ore is usually heated in the furnace. So why do we use the furnace? It is because we require high temperatures to heat the ore. So it is the furnace that can withstand the high temperatures. Just like how we see the kiln when they are burning bricks, that kind of fire. So we can take an example of a kiln as a furnace where there are high temperatures. So we put it in the furnace in the presence of a suitable reducing agent, which is usually coke, which is the same as carbon, or we can use carbon monoxide, which converts the ore into the required metal. Remember, at this stage we already have the oxide that we are reducing into the required metal, as we shall see when we go to extraction of one of the metals. Someone is saying that okay, sorry about Rebecca, sorry about that, but don't worry, after charging you have the lesson, and even there you will take your time, you can even watch while sleeping, so it is fine, but sorry about that. We shall send you the link. Finally, after having our metal, then we can refine or refine. So the metal here obtained, we are saying it is impure, meaning it contains some impurities, and we need to remove them. And here we can also apply electrolysis in the case of copper and zinc. So in case we are extracting copper or zinc, then we would purify those metals by using electrolysis. So those are the basic methods, basic stages that we use in the extraction of these intermediate metals. And here we are showing that in other cases, the impure metal is heated in earth open to air, where the impurities oxidize and rise to the surface as scum and can be removed. So our method that we want to look at or we want to extract is iron. But before that, if there is any question, it is time. If you have any question, it is time to ask. And evening to order. We are late by 7 minutes. Any questions? Any questions? Yes, Jose. Mugisa. Jose. Joseph, you can unmute.
I was saying that.
Joseph, you are not clear. You are not clear. Can you please use the chat? Thank you. So Elizabeth is asking, is it only the sulfur and carbon ore that become dioxides after roasting? Those are the ones which are common. But remember, we said that the carbon, the carbon is because we are using an ore which contains carbon. Like if we used iron to carbonate, so there is carbon. Then the sulfur comes in because of using a sulfide. A sulfide is from sulfur. So it depends on which ore that you use. But remember that ore or that compound must be containing the element or the metal you want to extract. Joseph again. Okay, so what I'm going to do, I'm going to send in the notes of iron also. So you will write all the notes, then when we meet next time, I will explain them first. That is if we come early for the lesson. So we shall have all these notes, we copy them down, then I will explain after. So that is it for today. That is it for today. Let's have Timothy Kenneth, please. Your video should be off. Even Francis. Let's have a volunteer to give us a closing prayer. Let me choose at random. Maria. Maria, you bless us so that we can also add it our records as well.
Heavenly Father, thank you for this class. Thank you that we've been here. We pray that all we've studied keeps in our minds also. As we are going, bless us, O Lord, with your wisdom. We don't forget what the teachers taught us. Through you, Jesus Christ, we pray. Amen.
Amen. Thank you.
Thank you so much. Thank you so much, Maria.
Have a nice day and a good evening. Thank you, Mr. Dumba.